Howdy guys, we're here to talk about Graham's Law. This is going to be the fourth video in this series and also the last one of this lesson. And note your homework. You don't have any worksheets to do tonight, so make sure that you are getting caught up on everything that you have missing, which you should already have turned in and done, right? So since we're talking about Graham's Law, this is on page 5 on in the back of your notes. This is the last part. Now, Graham's law is Graham's law of effusion or diffusion. Diffusion. Now, there's a very subtle difference between the two words. Effusion means that it is a gas is moving through something like a pinhole. So if we think of a box, so I'll draw a nice little box here. And wow, that's a nice box, Mr. Russell. All right, and let's make it three-dimensional. If we had a small hole in the side, the gas would be escaping through that hole, some molecules at a time. Now, that is what effusion is. So effusion is talking about something that goes through a small pinprick hole. Typically, usually defined as a molecule at a time. Now, diffusion is when it's not really going through a hole, gas is just spreading out. So, gas is spreading out. Spreading out. Please forgive my handwriting. I'm writing with not holding the pen right. So the gas is just spreading out almost, it's kind of like, you know, how smells will spread out. You can smell something from a long way away sometimes, especially if it really travels. So some gases travel faster than others, and that's what Graham's law has to deal with. It says that um, the rate of diffusion of the gas at the same temperature and pressure are inversely proportional to the square roots of their molar masses. So what this is saying is that as the molar mass or the molecular weight increases, the rate of diffusion will decrease. Okay, and also the opposite way. As the molecular weight decreases, the rate will increase. And that makes sense. Lighter molecules will move faster. Heavier molecules will move a lot slower. And the equation that's notated with this is going to be the rate of one gas divided by the rate of another gas is equal to the square root of the molecular weight of gas 2 divided by the molecular weight of gas 1. Now that is not a mistake. The rates should be catty-cornered to themselves. So we have gas 1 is right here and gas 1 is down here. When gas 2 is down here and gas 2 is up here. Okay. That's what an inverse relationship means, is they're catty-cornered. So I've gone ahead and cleaned this up a little bit to be able to do our example, which is example number 25, our last one. Which gas will diffuse faster, CH4 or SO2, and how much faster? So we need to figure out which one is the lightest, and we need to find our molecular weights right here. Since we know that the molecular weight of CH4 is going to be the molar mass of carbon, which is 12, plus the molar mass, 4 times the molar mass of hydrogen. That's going to be 16 grams per mole. And the molar mass of SO2 is going to be molar mass for sulfur, which is 32, plus 2 times the molar mass of oxygen, which is 16. So that's going to be 64 grams per mole. Well, looky there. Both numbers, 16 and 64, are perfect squares. Isn't that helpful? So what I should do is I need to remember my equation. Hold on, I just covered it up. My rate of CH4 is going to be divided by my rate of SO2 is equal to square root of the molecular weight of SO2 divided by the molecular weight of CH4. So that means that let's go ahead and put in our numbers for our molecular weight since we just found those. That's going to be 64 divided by 16. And you could divide this fraction and take the square root of that. Or I think it's easier to just to clean it up and to take 64 since I have perfect squares already. I have 64 and 16. You are allowed to do that. That's going to be 8 and that's going to be a 4. So that's going to be 2 divided by 1. So that means that the rate of CH4 is going to be twice as much as the rate of SO2. Okay? Because you're using a square root, you're frequently not going to get nice clean values like this. But so you're probably going to get a decimal, but it's okay to approximate just a little bit. So your answer should be CH4 will diffuse faster and it will diffuse twice as much faster. And that is going to be it. No homework tonight. Make sure you catch up on all of your stuff. Thank y'all.